Hey students, how you doing today? That's great. Thanks for all answering at once. Yeah, so chapter 6, we're going to do an abridged version of chapter 6, and one of my big motivations for doing this on video is because I know there's a lot going on right now, and this way you can go back and look at the lessons, and you'll know exactly what you need to know. So let me pretty much give you the outline of the entire chapter that we're going to need for this. Hey kitty, sorry, I'm at home and my cat is walking right in front of me. Kitty, I can't see the computer screen. Kitty, what? What do you have to say for yourself? Yeah, that's what I thought. Okay, awkward. So, what are you going to need to know for this chapter? Well, here are the major themes. We're going to need to know experiments versus observations. We've actually already seen that. We're going to talk about some experiment terminology, so some definitions, some words that we use in experiments. Then we're going to talk about the important parts of experimental design. And we're going to, really the big part of this chapter is going to be these 3 types of experiments that we're going to learn. Completely randomized design, block design, matched pair design, and then we're going to look at determining cause and effect through experiments as well. This video is going to cover everything up to completely randomized design. I don't want to put too much information out there. I will make a separate video covering block design, match pair, and then kind of wrapping it up about determining cause and effect. Okay, so you ready to get started? You excited? No? Too bad. Okay. All right, experiments versus observations. We've talked about experiments versus observations. What's the big difference between experiments and observations? Well, experiments impose treatment on subjects. Now, treatment, it's not really one of these words I want to define because it's got an ugly definition to it. But we've seen treatments before. We're comparing at least 2 differences between, we're comparing 2 different factors between 2 groups. Kitty. Alright, and we've talked about this too. We cannot determine cause and effect through observational studies alone. Why is that? There's just way too many lurking variables that we have absolutely no control over. We've seen this in chapter 4. We talked about this. And this is going to be a big theme. Why do we do experiments? We do experiments because we ultimately do want to be able to determine cause and effect. And we can do that through a properly designed experiment, which is exactly my point right here. We can determine cause and effect through a properly designed experiment. All right, we're going to work on this example today. Suppose that you work for a company that makes a drug to lower blood pressure in patients with hypertension. Hypertension is people with high blood pressure. So your company has an original drug, but engineers, I guess biochemical engineers, have come up with a new drug that still needs to be tested. So you have access to 40 volunteers with hypertension. How can we see if this new drug is going to work? So suppose maybe the first brilliant guy at your company says, hey, what if we give all 40 drugs for 8 weeks and we measure the blood pressure after those 8 weeks? Is this a good method? So you're giving all 40 of the drugs and you're going to see what their blood pressure is after the trial. No, it's not. And why is it not a good method? Because this is really an observational study, or at least there's no treatment. There is treatment with the drug, but you're not able to compare it in any way. So it's really an observational study, and we've learned that we cannot determine cause and effect through observation. For example, there's just many lurking variables, as I'd mentioned. And think of all the lurking variables for this particular situation. Well, I'm going to choose the weather. For example, maybe the weather may have improved during the end of the trial, which could have possibly lowered everybody's blood pressure. So maybe the first 8 weeks, or the first 7 out of the 8 weeks was stormy, and it was dark and gray, and nobody was happy. And then all of a sudden, the last week was just fantastic weather, and everybody was all calm. And now all of a sudden, maybe you have measured a lower blood pressure, but is that the result from the drug, or is that the result of the weather? It would be really hard to tell through this poorly designed study, which is exactly why we cannot determine cause and effect through an observational study. Okay, let me talk about some definitions. Oops, no, what did I do? Okay, they all came up at once. That's okay. So experimental units or subjects, these are the individuals in an experiment. So this goes down to the nitty-gritty. What are you measuring? Who gets the treatment? Those are going to be your individuals. And if those are people, we call them subjects. They don't necessarily have to be people. We can do experiments on cats. I don't think my cat liked that. We can do them on cars. We can do experiments on tractor trailers. We can do experiments on just about anything. But when they're people, we usually call them subjects. Otherwise, they're called experimental units. The response variable. This is the variable that we're actually interested in measuring. So we'll get to that example in just a minute. But maybe I'm trying to see, will my car go faster with this tire or this brand tire? Well, at that point, the individual is my car, and the response variable, I'm measuring time, or speed in some way. Confounding variables. This is when two variables interact in an experiment, and it's not possible to determine how each variable affects the response. For instance, okay, let's get to our example right now, and I'll show you that example of confounding variable. Okay, so with our blood pressure example, what are the experimental units? What's the response variable? And can you maybe identify two potential confounding variables? I'm going to give you just a minute to think about this. Okay, experimental units. What are the individuals in this study? Well, the experimental units are... Oh no, they all came up at once. No, you can't see that. You saw nothing. The experimental units these are the 40 volunteers who signed up. Why are they the units? Because they're the individuals that are going to end up with the treatment, which, again, the treatment in this case is going to be the drug. Well, what is the response variable? What are you going to be measuring? Well, what are we measuring? What are we trying to measure? We're looking at their blood pressure, right? We want the blood pressure to be lowered, so we're obviously going to be measuring the blood pressure. Now, how about two confounding variables? There's many possibilities for this one. I came up I came up with the weather, which is only one. The weather and, let's say, the effect of the drug itself. So let me just expand upon this idea of confounding variables. Let's pretend that what I said was true, that the first 7 weeks of the study were really horrible and the last week was really nice. And let's also kind of imagine that, hey, maybe this drug is actually working too, so that it works. And at the end of the study, we measure, hey, we found that this drug lowers blood pressure. Well, how do you know, is it the weather or is it the drug, depending on your design? Or how do you know that it's a little bit of the weather and a lot of the drug, or a lot of the drug and a little bit of the weather? So that's the idea, is that these variables are confounding, and you don't know what's going on, which is affecting more, which is affecting how much. Maybe quite the opposite. Maybe the first 7 weeks of the study were great, and the last week of the study was really bad. Now, and if we still measured a difference in blood pressure, we still don't know whether the weather or maybe something else confounded in our experiment without doing a good experiment. Okay, principles of experimental design. There's a few basic principles we need to design an experiment. And principle number one is control, or what I'll call treatment. We need to assign some kind of treatment. There needs to be at least 2 treatments. I don't know where that word "at" came down there. We need to have at least 2 treatments so we can actually compare the results. So we have a baseline. So we have something to compare with another thing. So rule number one of experimental design is we need a treatment. We need to control that treatment. We need to decide what treatment is what. And there could be more than 2 treatments as well. It doesn't necessarily have to be only 2. Next one is random assignment. This is probably one of the biggest parts of experimental design. Subjects or units, they need to be randomly placed into treatment groups. This way, each subject has an equal chance of being in any group. It would be extremely unfair if I did this blood pressure experiment and I took all the healthy people and put them in the group that got the drug, and maybe all the unhealthy people and put them in the group that didn't get the drug, or something like that. And without that random assignment, you don't know who has... I should actually say, without that random assignment, you don't... this way, everybody has an equal chance of being put into any group. So hopefully you don't have all the healthy people in one group and all the unhealthy people in the other group. Last one is replication. You should have a large enough sample size so that any difference between 2 groups can be deemed significant or not. This word significant is actually a fairly important word in statistics. In other words, just to kind of give you an idea, let's say we ran the trial and we did have 2 groups, 2 treatment groups, and let's say in one group there was a difference of 1 unit of blood pressure, and maybe you ran it again, the same experiment, but there was a difference of 3 units of blood pressure. Are these results significant? And what do we mean when the difference between 2 groups is significant? The idea about significant is that the difference between any 2 groups is significant if that difference is so large that it's not likely to be caused by chance alone. In other words, it's probably not just a random chance that it happened. It was the effect. It was maybe if we did a good experiment, we ultimately want to be able to say, hey, it was the drug that caused a significant reduction in blood pressure. Significant, again, being that it wasn't caused by chance alone. It's very unlikely that it was caused by chance alone. All right, we're finally ready for our experimental design number 1, called the completely randomized design. And it's a fairly basic design of an experiment, and just the idea is we have 2 or more treatment groups, and we randomly assign units or subjects into those groups. So the idea would be we'd start with some experimental units, and we randomly choose a certain amount and put them in one treatment group, randomly choose another amount, and put them in a separate group, and then compare the 2 treatments. But of course, it doesn't have to only be 2 treatments. It can be more than 2 treatments. For example, we can start with experimental units and maybe have 3 treatment groups. And also, the sample size for each treatment group doesn't necessarily need to be equal. It's usually nice if it is. Just an example. Maybe I was still doing this experiment, and I had maybe some group people in the old drug, some people in the new drug, and maybe some people who didn't get the drug. So now I could be possibly comparing 3 groups. And again, maybe financial reasons or whatever only allows me to have a certain amount of people in each treatment group. When we actually do the math on this, the math will take the sample size into account in determining whether differences are significant. That is for another chapter, so don't worry about the math part of this chapter. We also just need to talk about control groups and placebos. We call a control group is a group that receives no treatment and kind of serves like a baseline for the study. Now, it's very common, especially in medical studies, to give subjects in a control group what's called a placebo. And a placebo is a fake treatment given so subjects believe that they're actually receiving a treatment. Why would we give them a placebo? I'm going to talk about this in a little more detail when we talk about our example. But the idea is that a placebo can eliminate psychological factors or lurking variables that might arise in a study. Oh, you're not giving me any drugs. You're not giving me this new drug. Well, why should I believe this is going to happen? Why should I work out? Why should I do anything? We'll talk about that in just a minute here. So let's try to actually design a good, completely randomized experiment for this particular situation here. And we're just going to do one using a control group. Sorry, we're going to use 2 groups, 2 treatments, one being a control group. So the first thing you want to do is essentially you want to randomly assign your subjects into treatment groups. So you might want to discuss how you're going to randomly place them into groups. So first, I would assign each of the volunteers a number 1 through 40. Again, each of the 40 volunteers in this case. I'd use randint on my calculator, 1 through 40. Together 20 unique numbers, omitting repeats or skipping repeats. Okay, that's not too bad. The first 20 who were chosen will receive the new drug for an 8-week trial, and the remaining 20 subjects will receive a placebo, and they will act as a control group. I will measure everyone's blood pressure at the end to see if there's a significant difference between the blood pressure of the 2 groups. So I want to just talk about that control group again. Why would they receive a placebo? What is a placebo? So often a placebo is a fake pill. It's usually made out of sugar. It's a fake sugar pill that will look exactly like a real drug. So imagine here you're a patient and you're one of these 40 volunteers, and let's see why a placebo would be a good idea. So let's pretend that by random assignment you fell into the control group. But let's pretend instead of giving a placebo, let's imagine that instead of receiving a placebo, you're pretty much given nothing. So you go in, the doctors tell you, hey, you're in the control group, we're just going to measure your blood pressure in 8 weeks. Okay. You're probably going to live life as normal. You may or may not care. Well, let's pretend now, new situation. you're still in the control group, but instead of getting nothing, pretend they give you this placebo, this fake sugar pill, but you don't know whether it's a real pill or not. So you're taking this probably thinking, hey, I'm getting this drug. This drug is supposed to lower my blood pressure. It's probably going to at least give you some kind of psychological effect. And it's going to rule that psychological effect out as a factor. In other words, if I didn't have that control group, if I didn't have that placebo, and I was getting the medicine, well, now all of a sudden, how do I know if there was a significant difference at the end? How do I know whether that difference was because of the actual drug, or maybe it was just this psychological feeling that, hey, I'm taking this drug, it's going to help lower my blood pressure. So that's the whole reason for a placebo. So I could just diagram what I did to design that experiment. Fairly simple, straightforward diagram. Take the volunteer groups, randomly place them into two groups, and I probably should have mentioned how many people go in each group, and let's just say that I'll call this N1 will be 20, will go in this group, and N2 will be 20 in that group. And boy, that was the lesson. So I want to just go back to that first slide to remind you what we're doing in this chapter. So we talked about experiments versus observations. We talked about some terminology, some definitions. We talked about those three principles of experimental design. That was control or treatment, random assignment, and the last one was replication. And we talked about types of experimental designs. Sorry, we actually only mentioned this one, but we started it, so we still have this one, and this left to go, and that'll be your whole chapter 6 in 22 minutes and 20 seconds. Thank you.